So I left you hanging in the last video. I told you about these 3 different curvatures of the universe and the 3 different ways that it was going to die. And I said that in terms of which universe we actually live in, the answer is none of the above. Well, it's sort of one with a real special extra something. So again, astronomers wanted to know which universe we lived in. So what we want to do is we wanted to measure how the expansion of the universe is changing over time. And in all 3 of these models, the expansion of the universe slows down. It slows down the most in a closed universe because eventually it will stop and then reverse itself. And it slows down the least in the open universe and somewhere in the middle for a flat universe. So if we could look at very distant galaxies and measure the expansion of the universe back in the past versus the expansion of the universe now, we would be able to tell, hypothetically, which universe we lived in. And the bets were that it was open or flat. Pretty much none of the evidence suggested closed, although the idea of the Big Crunch is really cool. But again, being really cool does not make a model correct. Remember, science is not a democracy. So, in the mid to late 1990s, 2 independent groups of astronomers were measuring the distances to very distant galaxies, again to figure out how the rate of the expansion of the universe was different billions of years ago compared to now. And both of these groups independently came up with a completely unexpected, bizarre, crazy, wonderful answer. The universe is not slowing down. It's getting faster. Pedal to the metal there. Put that accelerator all the way to the floor. Buckle your seatbelt, going to be a bumpy ride. The expansion of the universe has actually been speeding up for the past few billion years. Now, we don't know exactly if it's going to continue doing that for billions and billions of years to come. In order to answer that question, we have to know something about what's causing the universe to accelerate. All we know for now is that it is some mysterious particle known as dark energy. Really, really bad term. And dark energy, whatever it is, and there are a bunch of different models for what it could be, dark energy right now is the most important component of the universe. The action of dark energy is counteracting the gravity of all the stuff in the universe that would try to slow the universe down. And unless we know the properties of this dark energy, we can't say if the universe will continue to accelerate in the future. There's one model that says that the universe might continue to go faster and faster until it ultimately shreds itself, rips itself apart. This is something called the Big Rip. Again, really cool sounding idea. Being really cool doesn't make it right. Need more evidence. But what does this mean to our models up here? Well, the universe we live in is geometrically flat. It is like this. But because of the presence of dark energy, even though geometrically it is flat, the evolution of the universe is not this. The evolution of the universe is this. And again, we don't know if we're going to continue to be accelerating.